Good morning, students. Today we are going to discuss about digital electronics subject in 5th unit, logic family properties. I am Dr. Gnanasekar, Department of Medical Electronics, Savitha Engineering College. The properties of digital ICs, which is mainly should be known, familiar, not only with their logical operation, but also such operational properties like voltage levels, noise immunity, power dissipation, fan in and fan out, propagation delays. The main supply voltage designations. The supply voltage for various families have names which are based on the type of transistors used in their construction. For TTL gates are made with bipolar transistor which have a collector and emitter, so the supply voltages are VCC and ground is occasionally given as VEE. And for CMOS gates are built with field effect transistors which have a drain and a source, so the supply voltage are VDD and VSS. Voltage limits, the first property. While the ideal voltage in TTL circuits are 0, that is logic 0 or low, and 5 volts, that is logic 1, that is a high, the typical or observed voltage are different in practice. It is important to know what tolerance must be observed in order to guarantee the correct operation of digital circuits. For particular quantity of or of interest in specifying the tolerance. The voltage in high minimum, the voltage in low maximum, the voltage output high minimum, the voltage output low maximum. So here you can segregate as the minimum input voltage which will be accepted as logic 1, the maximum input voltage which will be accepted as logic 0, the minimum output voltage representing a logic 1 state, the maximum output voltage representing a logic 0 state. Here for the 3 logic families listed as an example. So you can see the table where 3 different families, that is TTL, LSTTL, okay, that is nothing but low Schottky TTL logic. TTL is nothing but transistor logic, and the third one is CMOS. So you can see the minimum input voltage and minimum, that is maximum input voltage, similarly minimum output voltage and maximum output voltage with a range from 2.8, 2.4 to 0.4. So you can see the variations for 3 different families. While noting it, you can see the CMOS logic VDD can be as low as 3.5 volt and as high as 15 voltage. What the above information mean is, for instance, if input to a 74LS04, that is NOT gate, is at greater than or equal to 2 volt, it will be considered as high. And so the output should be low, that is at a voltage less than or equal to 0.5 voltage. Let us assume with a diagrammatical information showing the minimum voltage level and the maximum voltage level for input and minimum output voltage and the maximum output voltage. The yellow pattern gives about the noise immunity level and the small gaps between the input minimum and the output minimum, and similarly the input low maximum to output low maximum. So here we can see the 2 different things, 2 different waveforms shows about the indeterminate region, that is the yellow region. Indeterminate means where no value can be specified. Noise immunity. Noise is the unwanted voltage that might add to the output of the gate. It may cause the voltage of the input to a logic circuit to drop below input high voltage, or rise above input low voltage into the intermittent or illegal region to produce undesired operation. In order not to be adversely affected by noise, a logic must have the above ability to tolerance noise signal, which is referred as noise immunity. Noise margin. So the gap between the high level noise margin and the low level noise margin, that is V out H, that is minimum output, minimum voltage minus input minimum voltage, and that will give about the high low, that is high level noise ratio or margin. And next is the input low maximum minus the input output low maximum, which gives out the low level noise margin. Comparing TTL and CMOS noises, where this image gives about the clear information for TTL and the CMOS, where you can see the noise margin varying. For TTL it is 0.4 voltage, whereas for CMOS it is 1.5 voltage, which is very high. That is basically you can see the waveform. That is a diagram which it represents. You may introduce almost 1.5 volt of unwanted noise in CMOS before getting unpredictable results. So see an example where there is 7-4 LS series, which already told about for an AND gate. Those values where you can predict for the exact solution. So you can see the value substituting in the high level noise margin and the low level noise margin, giving about a value 0.7 for high level noise and 0.4 for low level noise. Next is the current limits. Similar to that of a voltage limits, the limit to input and output current of individual gate for particular quantities similar like B, that is voltage limits. So there is input high maximum, output high maximum, similarly input low maximum and output low maximum for current limits.